Assalamu alaikum. I'm Dr. Pervez Ahmed. In today's lecture of nuclear physics, we will discuss about solid state and semiconductor detectors. Uh, the first phase, we will discuss a little bit about the solid state detectors. Solid state detectors normally we also call them semiconductor detectors. So, and these radiation detectors normally we use a semiconductor materials such as silicon or germanium crystal. These kind of the material, the semiconductor material is constitute the detecting medium. I mean, it's the main part, just like we mentioned in the previous detectors that we are using some sort of the materials. So here we say that in solid state detectors, normally we utilize the crystal. We utilize the materials, and the main materials which are being utilized are silicon or germanium crystals. We are saying that these mainly constitute the detecting medium. So what is mean that uh, and the detecting medium that we are saying that should be silicon or germanium crystal. The electron hole pair are produced when a particle of the ionizing radiation passes through air. So what we have, it means that we have the silicon or germanium crystal and solid state detectors, and the ionizing radiation, that is we let's suppose we have the neutron or the alpha particles. So these radiations are meant to interact with the crystal, which normally maybe of silicon or germanium. So as a result of that interactions, what we have the electron hole pair. uh, as a result of that interactions, when the radiation passing through it, so as a result a pulse of current generated, and you know that that current which is being generated as a result of the interaction is measured, and it gave us a sense of radiations detections. So operation HPG detectors required liquid nitrogen. In this kind of detector, we normally need a liquid nitrogen for its operations. So you can view here, normally in solid state neutron detectors, we normally utilize a PN junctions here. So in PN junction, you already know and from your electronics course that what is mean by PN junctions. You see that here on one side we have a p type material, and other side we have n type of materials. So when we apply the voltage class 2, what actually happened that the positive ion are that in solid state, we say that the hole they are tracking toward one electrode. They are moved toward the one electrode, and the electron they are moved toward the other. So this is the main thing, the main concept that we are utilizing in solid state neutron detectors. So when you're using a solid as a detector medium, so what actually happened in this kind of the detectors when we are using a solid as a medium? So in many radiation detection applications, the use of solid medium is of great advantage. This kind of medium is of great advantage if you are using it in many applications. So how is that? For example, for high energy electrons and gamma radiations, solid state detectors are much smaller than the gas field detector. The one advantage that we have for for using the solid state detector is that it's comparable size. That is, it has a smaller size as compared to the gas field detectors, and energy resolution can be improved by increasing the number of the charge carrier. This is another advantage is by using a solid as a medium. That is, we can improve energy resolutions. How we can improve that? It can be improved by simply increasing the number of the charge carriers. This is only possible in semiconductor detectors. This kind of thing was not possible and the previous detectors we have discussed in the last lectures. So, semiconductors, the desirable features of the semiconductors are solid state detectors normally comes in that it has, or this kind of the detectors normally have superior energy resolutions. They have the compact size, fast timing characteristic. I mean, it has fast timing characteristic, effective techniques. That is, it can be varied according to the requirement. I mean, the techniques of the material, the techniques of the device can be varied according to the requirement. I mean, what kind of, we need it for what kind. I mean, first of all, we look upon our requirement, and then accordingly we change the element, or we change the device according to that particular requirement. The semiconductor materials that normally we use here, and semiconductor detectors normally it consists of silicon, and be remembered silicon is used for the charged particle spectroscopy. I mean, if you want to have or to do the spectroscopy with the semiconductor detector. So we remember that in that particular condition, we utilize silicon as a semiconductor materials. But if you want to do gamma ray spectroscopy with the semiconductor detectors, so the materials, the semiconductor material which will be utilized or which will be used in a semiconductor detector, that will be germanium. So we can utilize two kind of semiconductor materials. I mean, depend upon your application, depend upon your interest for. I mean, first of all, you have to determine, you should think about for what particular application you are using that. So if your application is that is you want to detect charged particle, you want to do the charged particle spectroscopy, so in that particular conditions you have to utilize a silicon. uh, but if you are interested for gamma ray spectroscopy, so in that particular conditions you have to use the semiconductor material as germanium. So the typical structures of the semiconductor detectors, just like you can see it here in the picture, we have anode. This part is the anode, and this part is the cathode, and the middle we said that we have the intrinsic depletions region. So it's a very easy structures, very simple structures. So in that particular conditions, if you have studied the electronic course and the physics. So, and the operation mode, what we have, when a positive voltage is applied to the n-type materials. I mean, here we say that one side we have n-type materials, and the other side we have p-type materials. This p-type is n-type. So what we have, when positive voltage is applied to n-type materials and negative voltage to the p-type material, just like you can see it here, it's positive voltage, negative voltage. So what actually happened, the electrons are pulled further away from these regions, creating a much thicker deflection region. You see here, the electrons being moved toward the cathode. I mean, it's been attracted here when we applying the voltage, and the holes, they are being pulled toward this particular regions. So here we say that we have a very thick depletion region. This is the depletion region. So what happened after this, the depletion region act as a sensitive volume of the detector. So now this region, which we call the depletion region, this depletion region, it's act as a sensitive volumes of the detectors. So what happened after that, the ionizing radiations entering this region, I mean this particular region that we call the depletion region. So when the ionizing radiation entering this region, it will create hole and excess electron. I mean, when the ionizing radiations enter this particular region, so what actually happen, it creates hole and excess electron. So what happened with this hole and the excess electron? these migrates and cause an electrical pulse. I mean, it's, when we have the ionizing radiations and interact with these particular regions, so it produces electron hole pair, and these electron hole pairs and then migrate and cause an electrical force, and that electrical force shows the detections of the that particular ionizing radiations. So you have a semiconductor detectors and you want to utilize that for the gamma rays detection. So what we have, uh, when we have the gamma rays, you have a solid state or semiconductor detectors. So gamma rays transfer energy. I mean, here you see that we interact, uh, we have interaction between the gamma rays and semiconductor detector. So what actually the gamma rays do, gamma rays transfer energy to electron. So what happened, I mean, the process look like, I mean, if you know in physics about the compton scattering, I mean, you know about the compton principle of compton scattering. So what happened after the gamma rays transferring its energy to the electron, so these electrons traverse the intrinsic regions of the detectors. So this is the key idea for the semiconductor detectors when we are utilizing that for the detection of the gamma rays, that we can take help from the compton scattering. So this is all for this lectures. See you in the next lectures.